Alright, so welcome to this next video. In this next video, we'll be dealing with a concept called the chain rule. So differentiation using the chain rule. So you will see that in your formula sheet, you are given the standard form of differentiating a normal power rule. But also when you've got a composite function, then you can derive it by deriving the outer function first and then deriving the inner function. So you get up differentiating questions that look a little bit like this. So let's make this a little bit bigger for us to do. So what we'll then do, you can clearly see here, we've got this as a composite function. So we can find the derivative of this dy dx by simplifying the outer function. So bring the 10 down, keep that 5x. This now becomes to the power 9. And then once you start doing that, you can multiply by the derivative of the inner function. So the inner function becomes 12x minus 5. And therefore, this is you have differentiated this using the chain rule. Let us dive deep into doing some more questions. So with this one, before we differentiate, we'll get this into a form that we can differentiate. So this becomes 2x minus 1 all to the negative 4. And then we are happy to take the derivative here. So we'll keep the 2 outside. So we will differentiate the outer function. So we get negative 4. And then we get 2x minus 1. This becomes to the negative 5. And then we'll multiply by the derivative of the inner function. So 2x minus 1, the derivative of that is simply 2. What we then do in our last line is simply multiply everything out. 2 times 2 is 8. Times 4 is negative 16, 2x minus 1 to the minus 5. You can leave your answer in a positive exponent if you want, and what that will look like will be minus 16 in brackets 2x minus 1 all to the 5. So that's how that'll work out. Let's do some more questions. Now, if you had a function like this, the way that you would then do this, first of all, you would rewrite g of x and rewrite it as 2x to the 5 minus 8x to the 3 plus 3x plus 2. And all of this we're going to raise to the power of a half. And this is a composite function. So now using the chain rule, finding the derivative of this, what the chain rule allows us to do is to do the function first. So we are allowed to do that. And then we can keep that as it is. Let's keep writing that down. This becomes, now you minus 1 from there, that gives you negative a half. And then we then multiply by the derivative of the inner function. So this becomes 10x to the 4. 8 times 3, this becomes minus 24x squared. And then the last function plus 3. So now this is how you'd be able to find the derivative of that function. So if you want to leave it in the positive answer, so this will give you that 10x to the 4 minus 24x squared plus 3. This is going to be over 2 times x to the 5 minus 8x to the 3 plus 3x plus 2. And this will just be the root of that if you want to leave it in positive exponent. Let's do our last question quickly. So in this case, as you've guessed it, so this is not in a standard form yet, so we can get it into this form. Next up, so this will end up just being the 2x to the 3 minus 5x squared plus 4x minus 1. And all of this is going to be to the negative 1 over 4. Because we're taking the 4th root of that. So now, because now that is a composite function, we can now take our derivative using the chain rule. So using the chain rule, we will bring the negative 1 over 4 to the outside. 2x to the 3 minus 5x squared plus 4x minus 1. And then obviously we'll minus 1 onto that. And when you minus 1, we get minus 5 over 4. And then we do the derivative of the inner function. So the derivative of the inner function simply becomes 6x squared minus 10x. This becomes plus 4. And then once you've done that, that is how you'll then be able to find the derivative using the chain rule. I hope this has made sense, and I will see you in the next video.